So good evening all.
Good evening.
Very good evening all. So this is a great day
Good
for
evening.
ICC
Good
today.
evening. Good evening.
Good evening. Good evening.
Yeah.
Good evening.
So right now we have 34 members for webinars now. നമ്മൾ start ചെയ്യാം. Meanwhile, other members will be joining soon. So it's a very great Saturday. This is a special day for ICEC because വളരെ relevant ആയിട്ടുള്ള ഒരു ടോപ്പിക്കിൽ we are going to have a webinar. And today I'm introducing you about ICEC, which is one of the very prominently progressing Civil Engineers Association right now in Kerala and stepping onto other states and even outside the country with a view of increasing the knowledge gain and knowledge sharing practices to get implemented within and outside the civil engineers community. And this is as a whole, the association is formulated with a vision of improving the construction quality and even the infrastructure growth potential by getting benefited from this sector towards bringing it to the young engineers too. So it's a very clear-cut platform wherein we are sharing our experiences, and every month we used to conduct these kind of webinars in which we will be inviting one of the prominent personalities in this particular sector to give a technical talk. So today I am inviting Engineer Murali Krishna sir for giving a welcome address. Over to you, Murali Krishna sir.
Thank you, ma'am. Thank you. Good evening, all. Audible, ma'am?
Yes, sir. Very much audible.
Okay. Good evening, all. Integrated Civil Engineers Council ICC conduct ചെയ്യുന്ന ഇന്നത്തെ ഈ വെബിനാറിലേക്ക് ആദ്യമായി എല്ലാവരും ഞാൻ ഹാർദമായി സ്വാഗതം ചെയ്യുന്നു. നമുക്ക് എല്ലാവർക്കും അറിയാം ICEC ഇന്റഗ്രേറ്റഡ് സിവിൽ എഞ്ചിനീയേഴ്സ് കൗൺസിൽ നോളജ് അപ്ഡേഷന്റെ ഭാഗമായി ഒരുപാട് പ്രോഗ്രാമുകൾ നാളിതുവരെയായിട്ട് കറക്റ്റായിട്ട് കണ്ടക്ട് ചെയ്തു വരുന്നു. അതിൽ വെബിനാറുകളും ഓഫ്ലൈൻ സെഷൻസും സൈറ്റ് വിസിറ്റുകളെല്ലാം കറക്റ്റായിട്ട് നല്ല രീതിയിൽ കണ്ടക്ട് ചെയ്യാൻ നമുക്ക് സാധിക്കുന്നുണ്ട്. ഈ മാസത്തെ വെബിനാറിനായിട്ടുള്ള ടോപ്പിക് നമുക്ക് കിട്ടിയിരിക്കുന്നത് സോയിൽ നെയിലിംഗ്, ഹൗ ഇറ്റ് വർക്ക്സ് ആൻഡ് വാട്ട് ക്യാൻ ഗോ റോങ് എന്നതാണ്. We all know soil nailing plays a crucial role in the stability of soil slope and preventing geotechnical failures, especially in hilly terrains and infrastructural projects. ഇന്നിവിടെ ഈ വിഷയത്തെക്കുറിച്ച് നമുക്ക് ക്ലാസ് എടുക്കുവാൻ നമുക്ക് ലഭിച്ചിരിക്കുന്നത് IIT പാലക്കാട് സിവിൽ എഞ്ചിനീയറിംഗ് ഡിപ്പാർട്ട്മെന്റ് HODയും അസോസിയേറ്റ് പ്രൊഫസർ കൂടിയായിട്ടുള്ള ഡോക്ടർ സുധീഷ് സാറിനെയാണ്. സാറിനെ കുറിച്ച് ചെറിയൊരു ഒരുപാട് കാര്യങ്ങൾ സാറിനെ കുറിച്ച് പറയാനുണ്ടെങ്കിൽ പോലും ചെറിയ ബ്രീഫായിട്ട് സാറിന്റെ ഒരു ഡെസിഗ്നേഷൻസ് പറയുകയാണെങ്കിൽ ഹീസ് കറന്റ്ലി ദ ഹെഡ് ഓഫ് ഡിപ്പാർട്ട്മെന്റ് ഓഫ് സിവിൽ എഞ്ചിനീയറിംഗ് IIT പാലക്കാട് ആൻഡ് അസോസിയേറ്റ് പ്രൊഫസർ ആൻഡ് ഇൻസ് എ ഫോർമർ associate dean IIT Palakkad and former associate professor Department of Civil Engineering Kazakhstan and former geotechnical engineer HR Engineering Services Miami Florida and former lecturer Department of Civil Engineering National Institute of Technology Calicut. സാറിന്റെ ഗവേഷണ മേഖലയിൽ സാറിന്റെ സമൃദ്ധമായ അറിവും അന്തർദേശീയ തലത്തിലും ദേശീയ തലത്തിലും ഉള്ള സംഭാവനകളും ഉള്ള നല്ലൊരു വ്യക്തിത്വമാണ് നമുക്കിന്ന് ക്ലാസ് എടുക്കാൻ നമുക്കിന്ന് ലഭിച്ചിരിക്കുന്നത്. സാർ അവതരിപ്പിക്കുന്ന ഈ സെഷൻ ഓരോരുത്തർക്കും പുതിയ അറിവും പ്രായോഗിക ബോധവും നൽകുമെന്ന് ഞാൻ വളരെ തീർച്ചയോടെ വിശ്വസിക്കുന്നു. വളരെ ബഹുമാനത്തോടുകൂടി സാറിനെ ഈ വെബിനാറിലേക്ക് ഞാൻ സ്വാഗതം ചെയ്യുന്നു. അതുപോലെ തന്നെ ഈ വെബിനാറിൽ ഇന്ന് ഇവിടെ പങ്കെടുക്കുന്ന ICECയുടെ തന്നെ എല്ലാ സ്റ്റേറ്റ് എക്സിക്യൂട്ടീവ്സിനെയും ICEC ഫൗണ്ടർ മെമ്പേഴ്സിനെയും എല്ലാ മെമ്പേഴ്സിനെയും പിന്നെ ഇന്നിവിടെ പങ്കെടുക്കുന്ന എല്ലാ എഞ്ചിനീയേഴ്സിനെയും വളരെ സ്നേഹത്തോടെ ഈ വെബിനാറിലേക്ക് സ്വാഗതം ചെയ്തുകൊണ്ട് നിർത്തുന്നു. നന്ദി. താങ്ക് യു.
So, thank you, Engineer Murali Krishnan. Thank you, Engineer Divya. Thank you very much, ICEC, for inviting me for this webinar series. In fact, Rahis had contacted me early last month. I think the beginning of last month. I think towards the end of last month. But I was not available till now. So yeah, sorry about that. So I think I am audible, right?
Yes, sir. Yes, sir. Very much.
Yeah, okay. Yeah. In case, like, is there any break, please let me know.
Sure, sir.
As you both of you mentioned, this soil nailing, we have seen, like, we have witnessed many soil nailing failures in Kerala in the last couple of monsoon period, right? And we have seen lot of news cuts, like many things, like, whether this technique is suitable in Kerala soil conditions, especially in residual soils like lateritic soil. And also there were many statements, like even in one of the Malayalam news, you might have seen, like Kunnugal, Tunnikattanavamo, like there were many such statements. So I am not going to the, that whether this technique is suitable in Kerala soil condition or not, but I want to focus more on like how soil nailing works, like what is the mechanism behind the functioning of soil nailing, and what can go wrong and what can lead to the failure of soil nails. So then you can decide whether this is suitable in Kerala soil condition or not, because I don't want to comment on that. But yeah, but at the same time, like, this is, we have to keep in mind that this technique is a well-proven technique, and is being used across the world successfully. So we have seen there are different types of retaining structures, like, in our, as a civil engineers, we come across and we design, construct different types of soil structures, either for different actually serving different purposes, like, preventing soil movement in some cases, or when you want to keep the grades at different levels, maybe in vertical or nearly vertical, or sometimes if you want to stabilize slopes, or if you have some structure and you want to protect that from the other adverse effects. Such cases we go for retaining structure. There are different types of retaining structures, right? Starting from gravity retaining wall, cantilever, counterfort, then many other. But based on this construction approach, we can broadly classify this into two categories. One is bottom up approach, and the other is top down approach. So in bottom up approach, like, most of the retaining wall, like, the gravity retaining wall, cantilever, counterfort, then our reinforced earth wall, all these are coming under this category, bottom up, because we are starting the construction from the bottom, right? Then we go upward. For example, cantilever wall will be first constructing, leveling the ground, and then constructing the base slab, then going upward. Reinforced soil, again, like, we are actually putting soil in layers and then put reinforcement and compacting layers. Whereas in the other approach, like top-down construction, like, we are actually installing or constructing from the top in the downward direction. So one of the good examples is like soil sheet pile wall. Sheet pile, we are actually driving this from the top, right, into the ground. So similarly, soil nail, like, we can consider under top down, even though we can use in bottom up construction. Sometimes, like, just like reinforced soil, we can use it, like, we can put soil compact and put nails and do that, or we can first fill and compact, then we can install it from the top to bottom. But typically, especially for excavations or even vertical cuts or slopes, we generally start from the top and progress in the downward direction. We can do the other way as well in some special cases. Similarly, diaphragm wall, secant pile, tangent pile wall, soldier pile, all these are coming under top-down construction. Now, let's focus on soil nail. So there are different types of soil nails being used in practice, like, drilled and grouted, which is the most commonly used one. Then we have a self-drilling. Then we have jet grouted, helical driven, shoot-in nails. So among this, as I told you, like drilled and grouted soil nails are the most popular one. So wherein what we are doing is, this is actually a photograph of drilled and grouted soil nails. So what we do here is we drill a hole. Let's say if you have an existing slope, we drill a hole. Then we insert the rebar. It's actually a passive reinforcement. So we generally a rebar or a tendon, we put it typically minimum diameter is 16 mm. So this we put, we'll have some spacers as well to ensure that this is exactly in the middle of the hole. Then we pour grout. This grouting can be done either like gravity grouting, we just pour, then fill it, or we can apply pressurized grouting. Pressurized grouting, we have to ensure that we have to use, in conventional pressure grouting, we have to use some packers to build the pressure, otherwise we cannot build the pressure. So pressure grouting, we can improve the its pull-out resistance significantly by pressurizing it. But it has disadvantage as well. Sometimes this grout may go somewhere else. We don't know if there are some cavities. It may keep going. So that can happen. So recently, we have developed a membrane-confined pressure grouted soil nail as well, and which we have applied for patent as well. So that what we are doing is we will be attaching a membrane, a polyester membrane around this, and so what is going to happen is this grout is going to fill that and it's going to expand. So grout cannot go anywhere out. Instead, grout is going to expand. So this is going to simulate a cavity expansion scenario and thereby improve the pull-out resistance significantly. But still, in practice, this pressure grouted nails are not common because of the contractor doesn't prefer that, because you have to pressurize it. So people always go with the gravity grouter because that is much easier. But if you need more resistance, they will increase the diameter or length. That's it. So pressure grouted are being used like some special situation, like where we have a limited space or some special situation, we go for pressure grouted. Otherwise, typically we go for gravity grouted. So now when we say what are the different components of this nails, I mean soil nails, as I told you, one is the reinforcement. The passive reinforcement, that is the rebar which we insert. Then the grout. Grout generally we consider cementitious grout, cement grout with a water cement ratio in the range of 0.4 to 0.5 and with a minimum characteristic compressive strength, that is 28 days compressive strength of more than 20 megapascal. Then we have this facing. Typically, we'll have two facing. One we call initial facing or a temporary facing, and the second is final facing. Okay, then we have to connect this rebar to the facing. For that we use nail head. This nail head, I'll show you some images in next slide. We will have a bearing plate, then typically square plate in the range of 20 centimeter to 25 centimeter. Thickness is more to suggesting you have to use 19 mm thick. Then a nut, X nut, and washers. Okay. Then another important component is the drainage system. That is very important. We will talk about that towards the end of this talk. So now the three important references which we generally use in Indian context are the MORTH specification for road and bridge work. That in that section 3200 is talking about soil nailing. Actually, it's only 4-5 pages, not going in detail. But FHWA manual, reference manual, is covering this soil nailing in detail. Okay, this is available online as well. You can download and use it. Then British code is there, BS 8006-2. That is again for soil nail, but that is not freely available. We have to pay for it. So these are the three codes generally we use in India for the design and construction of soil nailing. Now, again, if you look at the cross section, we can see here this part, the right one, left image I have already discussed, right? This particular case, we can see a dotted line, that is the original ground surface. Now, maybe in connection with the widening of a roadway also, we are cutting this triangular portion of the soil, and to support the remaining soil, we are using soil nailing. Though we have many other we can use for reinforced concrete retaining wall. The issue is the base slab. Of course, we can design with typically this retaining wall will have a longer heel slab, to, that heel slab is going to increase the momentum. Also, the soil on top of that heel slab is going to contribute to the stability, right? But we can also design with a shorter heel slab, and we can consider a longer toe slab as well. That way we can still increase the momentum, but we won't get the benefit of the soil, right, which we get on top of the heel slab. That is not there. So considering the cost efficiency, the contractors generally prefer the soil nailing. But as we have seen, we have to do it very carefully, otherwise it's going to fail. That is what we have seen. So my lecture is, this talk is more focusing on in that line. Now, if you look at the right image, you can see the connection between the rebar or tendon, how the tendon is connected to the initial facing. So this facing you can see here, this gray shaded initial facing, and this one with white with the triangular points, that is the final. So you have a bearing plate here. Then you have, when I move my cursor, is it visible?
Yes, sir.
Yeah, okay. So you can see here bearing plate, then we have a washer and then hexa nut. And then there is a headed stud as well. You can see here headed stud. The purpose of that is to connect this, this nail and the initial facing with the final facing. Okay, so you can see that we'll be tying this stud with this rebar or wire mesh of the final facing. Okay, so now let's see the temporary facing. Here you can see the left image. You can see here a wire mesh is typically used, welded wire mesh. Then you have a bearing plate at the location of each rebar, and Whaler bar. Whaler bar means, you can see two bars here that we put close to the soil nail. The purpose of that is to ensure the integrity of the facing, because there should be proper connectivity between the nail and the facing. Actually many people think like this, the purpose of the facing is just to prevent erosion or, or ensuring local stability. That is kind of true in the case of reinforced earth wall. In case of reinforced earth wall, we know that we have this reinforced soil mass with the facing, right? It could be either panels or modular block. That case, the purpose is not there. Actually, it's not directly contributing to the stability of the reinforced earth. Okay. It's actually provide a platform for a formwork for soil filling, and also it will prevent erosion. Third, it is going to provide stability against localized failure, and also aesthetic purpose. Whereas here, this is actually a structural element. This facing is a structural element, right? Yeah, we'll talk about that next slide. So this has to be designed properly. We cannot take it lightly, this facing, both temporary and permanent facing. So this you can see here. Now this is actually after the construction of permanent case, temporary facing. You can see each location you have 4 bars. That is actually studs. There is a central, you have this nail, and for the 4 corner of the place there are 4 studs. Now, then shotcreting, that is very important. Here after we place this bearing plate, Whaler bar, everything, then we spray shotcrete. So typically the thickness of shotcrete in the range of 75 to 200 mm. Okay, then above this, we have to put permanent facing. When to put, we'll talk in the next slide when we talk about construction sequence. But permanent casing is also, it could be either cast in place, just like this temporary casing. Temporary facing is always cast in place. Permanent facing can be either cast in place or precast. Okay. So also the reinforcement can be either welded wire mesh or rebars. We can use rebar, or similar, just like this temporary casing, we can use welded wire mesh. So as I just mentioned, it's connected to the temporary facing by means of headed studs. So thickness of this minimum thickness of permanent casing has to be 200 mm. Okay, means 20 centimeter. Now, one question, like, whether it is suitable in all the soil conditions. That is a question you all may have on your head. So basically, like, this codal, standards are suggesting some soil. So one way you can check is when you make a cut, or if you are able to cut, make a cut of 1 to 2 meter without failure for about 12 to 24 hours, then you can say the soil is suitable for soil nailing. Otherwise, like, when you cut it, what's going to happen? It's going to fail. You cannot use soil nailing. You have to go for some other technique. That is the first thing you can see. Whether you can make a cut of 1 to 2 meter and it can withstand or stand stable for at least 24 hours, then you. Secondly, during the excavation, if it's below groundwater table, again, this is going to fail. We cannot use. This has to be below groundwater table. I'm not talking about perched groundwater or anything. Typical groundwater table should not be. Otherwise, if it's a perched groundwater also, we can try for some dewatering technique or something just to make it stable till till complete in the construction. Then we have to use appropriate drainage provisions to ensure the stability. Now, what are the favorable soil conditions? One is like stiff to hard fine-grained soil. Like, fine-grained means, like clay soil, clay with clay silt, like particles, more than 50% is more, like passing through 75 micron. That case, we can consider it as fine-grained soil in general. So stiff to hard, of course, such soil, we can easily make a vertical cut without failure. Or dense to very dense granular soil with some apparent cohesion. That is very important. If you have a very dry sand, even if it dense, unless there is no cementation, even if you make a cut, it's going to fail, right? Because it's dry, you know that if you draw the failure envelope for sand, it's passing through origin, means no cohesion in it. But when it has some moisture content present in it, okay? When it has some moisture content, what will happen is this will have some capillary effect. You might have learned during your BTech, and those who have a MTech degree will have heard about this during their MTech program. This capillary effect is going to provide, like, this suction effect. We call it suction effect. Or it's going to impart some negative pore water pressure. Negative pore water pressure. So this negative pore water pressure is going to improve the effective stress in soil. Okay. So this effective stress in soil get improved. Means it's not going to fail. So it's going to impart an apparent cohesion into. So it won't fail. So that's why, when you perform a direct shear test in, sand with some moisture content, you will observe when you plot failure envelope, you might have observed a small intercept on the vertical axis. You know that even though, sand has to be 0, but you see something from experiment. That is because of this apparent cohesion. So dry sand is not possible, but sand with some apparent cohesion is possible. Now, weathered rock with no weakness planes means we can have weakness planes, but should not be, orientation has to be proper. Then engineered fields. Engineered fields means for reinforced earth wall. Sometimes what will happen is this, reinforced earth wall after construction with the time passage, you may observe some large bulging, maybe it may be associated with, some lateral deformation of this, whatever be the reason. Such cases, to stabilize it, we use soil nailing. Many cases, many stretch on NH 66, they have adopted this. Some already existing sections, some places they have adopted this soil nailing on the RE wall, MSE wall. Similarly, residual soil. So residual soil, our lateritic soil is coming under this category. But if you have mica and shale present in it, then you have to be very careful because that's going to make it weaker. Then glacial soils also. So residual soils, when we talk about laterite, when we say laterite means, it's heterogeneous, right? We know that it's highly heterogeneous. Its properties significantly vary depending on the mineral constituent present in it. It's formed by weathering of rock, right? So its properties depends on the parent rock and also the degree of weathering. That is also very important, degree of weathering. You know that some lateritic blocks we are using for construction in Malabar region, right? I'm actually from Kozhikode, and my house is actually constructed using this lateritic blocks. So that is very common in Malabar region. That's used as a construction material. But that material is good. You can easily make a vertical cut. But there are, when I traveled across, I have seen there are some weak layers, especially when you go to certain depth, you can see weak layers with more clay content. That is very soft actually. That is actually, in some cases like clay content and also sometimes more silt content, and that is also highly weathered. When you make a cut, it may be stable for some time because of this apparent caution. We'll talk about that. Uh, but long term it cannot sustain. Okay, that cases is that is why many cases it's failed. One of the reasons, not the just one. There are many reasons. One of the reason is this. Now, when we talk about this, okay, what are the different types of failures you can expect in soil nails? So here you see the top one, A. A is basically typical. Like you can see that this failure plane is passing through, or slip surface is passing through the reinforced area, right? You can see here. So that is actually kind of an internal failure, internal shear failure, slip failure, we can call it. Second case, you see this failure is similar to the first case, looking like circular. You can consider different failure surfaces, but yeah, but curvilinear, right? But you can see here this is outside the reinforced zone, and also the surrounding soil base is also contributing to it. So this is actually, we call it as a global failure. Global failure. Then when C is like when this is resting on a soft clay layer, which is underlined by a relatively hard layer. In such cases, you can observe because of this loading, okay, because of this loading, you have actually this side there is no loading, right? But this side you have loading. So you can expect some basal shear failure, or we can call it as basal heave. You can see there is a heaving at this side, okay. Then typical sliding shear failure, just like any other retaining structures like gravity retaining wall or cantilever or RE wall, you can expect this kind of shear failure, right? So shear failure also you can actually, when this happen, when you have a thin layer of soft material underlying this, so you can expect failure surface passing through this one, because this may be the shortest path for failure, and failure may happen. So sliding failure you can expect. So these three, A, B, C, are typically we can consider as mode of global failures. Okay, but D is a geotechnical failure, sliding failure. Similarly, E is basically a pull-out failure. Basically, what is actually happening is, uh, before I'll come back to this slide after discussing this. When you have a soil mass, when you want to make let's say this is a vertical cut, okay. So when you have actually, when you make a vertical cut, you have actually two zones here, right? One is this tendency to yield or fail like this, right? So this is actually the failure surface. But this side on we can say non-yielding zone, because that is not deforming, that is not. So shearing is happening along this one. So our intention is to prevent this yielding by installing soil nail. So what we are doing is, this is what we are doing, right? We are installing soil nail, and we have a facing here as well. Now, what is going to happen to this the portion of soil nail within the yielding zone? You are going to observe this zone. You see the shear failure is, since the soil is yielding outward and downward, you will observe shearing along this interface, that the surface of the grouted zone. I mean, the interface of the grouted zone and the soil, you're going to have shear resistance mobilized this way, right? Because, yeah, so this part is not contributing to the resistance, or this is not providing any kind of resistance. Whereas look at here, the portion within the non-yielding zone, you can see that this is actually mobilized in the opposite direction. Facing, Okay, that's why I told you initially facing is a structural component. Now from facing through the connection, the load is getting transmitted to the, hello? Hello, am I audible?
Yes, sir. Yes, sir.
Okay.
Now you are audible. Yeah.
Yeah. Yeah. So basically, so one is here you can see this load is going to act, this create tension on the rebar, right? You can imagine, right? Like this is actually tension on the soil nail, because this is actually load is acting outward, and from the facing it is getting transmitted as tension to the rebar. Now, as I told you, this zone you have skin friction mobilized this way towards the direct movement direction. So the resistance contributing is this one. You see here you have surface. So what will be the contribution? That will be equal to the surface area of the nail segment within this one. We call it as a bond length or zone. The length within this, okay, like within the only non-yielding zone. So that you can write down as, so resistance, pull out resistance will be equal to pi d LP, means pi d means the perimeter into LP is the surface area into unit bond resistance or unit skin friction along this. That is what actually. So this is a pull-out mechanism. So this is the most important mode of failure, pull-out failure you generally observe in this soil. So you see that typically for top nail, the length, the portion is smaller compared to the bottom. So the contribution of the top nail is relatively less, the long term, okay, but short term during the excavation process and or during the construction stages, this is contributing significantly, top nails as well. And also this is going to prevent local failure, okay, prevent failure in this zone, like the top soil, top area, top zone. It can prevent, like this area it can prevent. Now going back to the previous slide, so that is a pullout. So this is also a geotechnical failure modes. You can see here. So you have 3 global and 2 geotechnical, and the remaining F2I are structural. You see here, this nails can fail by tension, like tensile failure can happen to the nail. Similarly, bending of the facing can happen. Bending failure, flexural failure can happen to the this facing. Similarly, you can expect punching failure of the this facing. Then that failure of the studs, that also you can expect. So all this, we have to basically check all these failure modes. But typically that is not done. We may check like a pull-out failure, and typically these 4 F2I are not generally done, but that is not correct. We have to check for all these failure modes. No, I think I will make a short, like a 2 minutes break as per the request from the.
Yes, sir.
Yeah. So I think I will pause it here. You can let me know once that part is over. Yeah, please. Yeah, over to you, Engineer Divya. Hello. Yeah.
So everyone, please see the link in the chat box. E-link form fill here, so that you will be receiving the participation certificate just after the meeting. Okay. This link will be active only for 2 minutes from now. So ഇതിനകത്തേക്ക് details fill ചെയ്യുക participation certificate. And meanwhile, other members, those who are free after doing this form filling, നിങ്ങൾക്ക് എന്തെങ്കിലും questions ഉണ്ടെങ്കിൽ you can type it and put it in the chat box, so that sir session കഴിഞ്ഞതിന് ശേഷം address ചെയ്യാനായിട്ട് he will be prepared to.
Sir, is this soil nailing always put in an angle of 15 degree?
Sir, you're on mute. Sudheesh sir.
Yeah. So I think it's better to take questions at the end, right? Because
Yes,
some of the
yes, yes.
questions, answer I'll be discussing in the next
In the
30
presentation.
minutes. Yeah. So
Sir, he'll be addressing the question. Meanwhile, if at all anything is there, you can put it in the chat box so that finally address.
Yeah. Because some of this, like most of the questions, I don't know. I may be discussing. So if not, we can.
Yes.
Yes.
This time is enough, sir.
This particular question is anyway, like I'll be discussing. So yeah.
Okay.
So I think
Yes,
I
sir.
can continue.
You can continue, sir.
Yeah.
Yes, sir.
Okay. Yeah. Okay, now I think I hope this slide is clear, and especially this pull-out part is that is very important. I hope this part is clear. Now, because this is a pull-out mechanism is very important for soil nail. So here you can see that only the portion which is in the non-yielding zone is only contributing. So if you want more resistance, means you have to increase the length of the nail in the non-yielding zone, right? Now, so here see the equation, this equation, we have pi dLp, that is surface area, and unit skin friction, or we call it as bond resistance or bond strength, Q. This, how do we obtain this Q? That is actually, that is a value, typically we essentially need for the design of any soil nail. So there are some presumptive bond strength values given in the literature, like in the standards. Here you can see that this first table for I have taken this table from FSWA manual. So here you can see this is for the cautionless soil, the left one, and the right one for fine grained soil, means clay soil. So here you can see that for different drilling method, rotary drilling or augered cases, or different types of soil, even within cautionless soil, we can have different combination like sand, gravel, silty sand, silt, peatment, residual, fine, like that. So bond strength values are given in, this is in PSI, but we can convert it to KPA, and some other, textbooks and other, this PKPA is also available. Otherwise, we can convert. So here, see, you can see some cases they have given, for particularly this case, you can see sand gravel with low overburden or sand gravel with high overburden. So here they're talking about low overburden means, you see here in footnote, they have given 1.5 TSF. So this 1.5 TSF means it's about 160 kPa. Kilonewton per meter square. So that is equal. So if you are taking about a 16 kilonewton per meter cube soil into it, so this is equal to, which means for wall height less than 10 meter, they are considering low overburden, but for above high overburden. But even within this 10 meter, we have this nails at different elevations. Okay, but this can, this will have a significant influence because the top nails and all may not have that much bond resistance as the bottom nail. But if you are, so these values you can use in the preliminary design, but we have to do pull-out load testing to verify this. Okay, we'll talk about that. So now typical, initial design consideration will include, we have seen that the nails are inclined, right? Slightly inclined. So typically, the more FHW is saying like 10 to 20 degree. So now coming to that question, like 15 degrees, what is typically adopted? 15 degree. So why do we need to provide 15 degree? That is one question. Why can't we have it horizontal? We can consider horizontal as well, but the issue is if you are performing gravity grouting. When you pump grout to the hole, if it's horizontal, or 5 degree or so, what is going to happen? We cannot fill the hole completely. We may have some air pockets during the filling. But whereas when you have a inclination more than 10 degrees, 15 degree and all, this grout is going to completely fill the hole. That is one of the reasons for providing this. But there are some researches on what is a variation of pull-out capacity with inclination and all. Yeah, I'm not going to discuss that, but typically we provide 15 degree based on just to ensure that the grout is completely filled in the hole. Now the pattern of soil nail, we either provide in square pattern or rectangular pattern, or sometimes we put in triangular pattern, or sometime like special situation, like when in corners or somewhere, or some some restricted areas, constrained areas, we may need to provide in irregular pattern. And also spacing, again, we have to design it. It can be between 1.25 to 2 meter typically, but it can, you have to design it properly. Then permissible wall deformation has to be, this Morth is suggesting, for weathered rock and stiff soils, it has to be 0.1% of height, H is height. So if you are considering a 10-meter high wall, it will be 0.1% is how much? It's about 10 mm. Similarly, sandy soil, they are suggesting 0.2 H, which is equivalent to 20 mm in case of a 10-meter high wall, and fine grained soil 0.3. So what maximum suggested is 0.3% of height. Okay. Now, so here, if I go back to this slide, here, these first three, you have to use some software package. We can, for everything you can use software package, like up to E. But typically for first three we use software package. We cannot do it manually because we don't know. We have to consider a number of failure surfaces and identify the critical failure surface and corresponding factor safety. That is a critical factor safety, or the factor safety for the system. So we generally, Caltran, California Transportation Department, has their own software like SNAIL, S-N-A-I-L. It was the older one, and now they have SNAILS, S-N-A-I-L. Similarly, FHW has SNAP2, Soil Nail Analysis Program. And in India, we don't have access to these, but we can use other slope stability analysis software like GeoStudio, Slope W we can use. We can model soil nail also there, and we can perform all this analysis, A, B, C, using that. C, D as well. D, you can consider probably a thin, weak layer, and you can force to have the failure happen through this. So this 4 you can handle using such software package. Now, pull-out resistance, as I told you, if you know based on this one, if you based on the critical failure surface, which we generally obtain from this analysis, A, B, C, A analysis, whatever, you can, basically this analysis, we can identify where the failure surface is and what is the length of the zone, and accordingly you can calculate the pull-out resistance. Also, there are some charts available for the calculating the length of soil nails and load or tension on the soil nail. That is useful for F, and also the connection load as well. There are some charts available in literature that is actually published by Lesarte, and later textbooks like GHAN and all, it's readily available. We can use that also for designing purpose, or you can do according to this one, and then actually you can perform the analysis again. One, you can perform the analysis without the reinforcement, and then one with the reinforcement. Okay, then you can see how much factor safety improvement is there. If it is not adequate, you may need to increase the length of the nails. Especially sometimes increasing the length of the top nails may improve the factor safety. You may need to adopt that to ensure that what the factor safety available. So typically for pull-out and all, factor safety has to be more than 2. Whereas for this kind of failures, global failures, factor safety, recommended factor safety is 1.5. But some codes and all, they're suggesting like 1.3 as well. But I would suggest to go with 1.5. Yes, there are many other uncertainties which we don't account for. So we have to consider, better to consider a higher factor safety. Okay, now I hope these are clear. So far as clear. So this presumptive bearing capacity we are using, I just show you. So yeah. Now this part is very important, construction sequence. This is a stage where many contractors knowingly or unknowingly make mistakes. Most probably I would say it's knowingly. Yeah, because these are actually, even if you Google it, you can find construction sequence of soil nailing, you can get similar image. So any engineer can simply Google, whoever involving in this work, like soil nailing work, will be aware of this. They can just Google it. So that's why I'm using the term knowingly. So here what we have to do is, like, if you want to make a vertical cut of this, like one shown in the bottom most, we have to start. We should not do it in one stretch. Okay, we have to first excavate like about 3 to 5 feet, maybe like 1 to 1.5 meter. We can do it, then cut it. Then if it's not stable, what does that mean? This soil nailing is not suitable sometime, right? If not stable, then what you have to do is you have to drill a hole. You have to drill a hole. Okay. First, the top nail you have to drill. You drill a hole, then lower your tendon and then perform grouting. Then you put the drainage layer. We'll talk about drainage layer. Then put the wire mesh, and then for step 4 you are putting the you are actually shotcreting, or you are constructing the initial facing. Okay. Now once this is done, you proceed with the second stage of excavation, like 1 to 2. Again, perform the installation of the second nail and do everything, construct the initial facing, then go to the third phase. This is the way we have to continue. Okay. Then at the end, once this is over, completed, so you will have now everything in place except final facing, then you construct final facing. Okay. For a temporary structure, you don't need a final facing. For any permanent structure, final facing is important. We have to provide. Okay. Yeah. This is the stages we have to follow. But unfortunately, most of the failures are associated with not following the standard stage construction practice. Here you can see in this image, they actually perform full depth excavation. So, this is like their point of view, like, they can do it quickly and they can use the soil for some other places, like maybe for some other location, they may be constructing an RE1. So they can use the soil. And also they have to provide roadway, they should not disturb the transportation. So they have to provide it. So considering all this, they are actually doing this. But this should not be allowed, actually. We have to perform. So what is going to happen is when you make an excavation like this, as I mentioned earlier, in a hard laterite and all, it may work. But in case of soft lateritic soil and weathered soil and all, it won't happen. Highly weathered laterite and all, it won't happen. It's going to fail. If not, if it doesn't fail immediately, what's going to happen is there will be some uncontrolled deformation happens. There will be associated stress relaxation within the soil. Soil is actually going to relax. Stress is going to relax. Means, or other way, confinement is decreasing. So it may fail during, maybe now after they cut it, if a rain happen, because of the rain infiltration, it can fail. Localized failure can happen. That is what, many newspapers, some failures reported. That is because of this kind of uncontrolled, this kind of full depth excavation. Now, when you install the soil nail on this, do you expect the same pull-out resistance? No, right? Because the soil is already softened. Like there is strain softening happen because of this uncontrolled deformation. Right? Sometimes, they cut it vertically, but because of this deformation, it may be slightly overhanging. It may not be vertical, it may be slightly overhanging because of the deformation. So this is a big mistake, or knowingly or unknowingly, that the contractors make. And this is actually a basic mistake, and this should not be allowed, actually. That is one. And I'll show you many images associated where it can go wrong. Like one of this is, see here you see, this actually the same image was, this actually I have taken this image, but this same image I saw in one of the newspapers as well. Here you see how, this in the image, you don't feel that deep, but it's very deep excavation, in fact. Here also is very deep excavation. All these cases, they have simply cut it. They should not have done this way. They should have done it in stages. That is one mistake we can observe in this. Similarly, sometimes what contractors do is they just spray shotcrete, temporary spraying. Actually, this temporary spraying may prevent some localized failure that doesn't offer any structural benefit, right? Because if heavy rainfall happens, this water can percolate and increase the pore water pressure, and it can fail. So it's not contributing. Maybe temporarily it's supporting, but it's not. Many places this is happening, but yeah, this is not providing much. This simple shotcreting, no wire mesh, nothing. Okay, this they do after excavation, after a big vertical cut, they are doing this. Similarly, you see in one of the such cases, what has happened is they have put in top, you can see they have put just shotcrete spraying without wire mesh. Here you can see during rain, it has failed. Now they have put some gravel at the bottom, coarse aggregate at the bottom, just to provide stability or prevent further failure. This was not original part, but they have actually added it to it. Similarly, another scenario what may happen is like, this is actually an image of a drilling of nails. See here also they have put shotcrete initially. Here also you can see they have done this excavation all the way down. They have not done in stages. So here actually after drilling, sometimes what is actually happening is the contractors leave the hole open for an extended period, maybe 1 week, 2 week, 3 week, like that. You should not leave that. Once when you drill a hole, what is going to happen? Again, this hole may collapse, or also if not, the soil is going to relax, and actually the actual diameter may reduce because of this, like a kind of a contraction of this hole diameter. Soil is actually relaxing, means stress state around the hole is actually decreasing. This can also decrease the pull-out resistance. Also, if a rain happen during this period, it can fail. So this also not recommended. This is another reason. So here you see this particular case, but you can see failure here. Also, you can see nails here. This actually after soil nailing, this failure has happened. And actually they have taken wire mesh here. You cannot see wire mesh here. So here also you can see this, this stage construction is not adopted. So this shotcreting and wire mesh should be placed immediately. And also here you see there is no permanent or final facing, right? And also this failure may also be associated with improper drainage. We'll talk about drainage after a few slides. So this is another failure you can expect. This also associated with the improper construction procedure adopted. Here again, you see here this particular image also you can see nails and plates, everything. Wire mesh, again, wire mesh is not visible here, so it appears like wire mesh. They might have removed wire mesh because otherwise, this plate will not be there, right? So this particular case also, shotcrete thickness may be not adequate. Or and also sometimes you see because of this failure is bent. This bending of these nails also happen. So this particular case also the issues are improper, not adopting proper construction sequence, improper drainage, and inadequate facing. These are the three reasons for this failure. Of course, it can depends on soil properties as well. We'll talk about that in the coming slide. This particular case, you see, there is no final facing, and you can see this spacing between the nails were very high. About very large, like more than 2 meters. You see, this one nail here, another nail here, like that. The spacing is much more than 2 meters. So this is another reason. The design of nailing was not adequate in this case. So now, as I told you earlier, the initial design, we are using presumptive values that I have shown you in the tables, right? I think, time is 8:50. Yeah, I think I have a few more slides. Yeah. I hope that's fine, right?
Yes, sir.
Yeah, okay. Yeah, I don't want to rush. Yeah. So, so we have to verify this on site. That is very important. We have to, at the site, we have to perform pull-out load test. So we have actually, typically, we do verification test that is done before the construction. In the design phase itself, we have to perform this drilling operation. Construct a nail and perform pull-out load testing. And also after nail construction, after the construction of soil nail wall also, you can identify a few random nails and perform testing that we call proof test. That is just to ensure that meet the design pull-out resistance. So this left image, so I have taken from this FSWA manual, and this is actually a field. The right one is actually our own pull-out load test, which we actually done in a large model test. Actually, this our research students are doing testing. You have a load cell, a jack load cell, and some plates, and this is jack will apply load, and the load cell will measure the applied load, and then you have a displacement monitoring system, which include LVDT and a spring potentiometer. So, but we have to be very careful with this pull-out load test. Most of the time, these pull-out load tests are misleading, because what what is actually happened, they will have presumptive values, I'll show you some comparison, our on some experiment model test results we have in sand versus lateritic soil. See, this is what we got. Our case overburden stress was very less, like about 15 to 30 kPa. You see the bond stress value, what we got is about 10.3, 20.3. Lateral soil, it's even less, like 14, 12, etc. So, and also you can see in partially saturated versus fully saturated also this decreases. But look at the values I shown you in the table, FSWA values that we discussed in the previous table. These values are very high. You can see here. Because the reason is, we understand because we are dealing with a very small overburden stress. Now, my question here is like, so in our model test, we are representing probably the topmost nail or so. Okay. So, but in a typical design, what they are doing is they are using this value for all the nails. I'm not saying all the contractors, but designers, but many of them are considering the uniformly for all the nails. That is not correct. So we have to consider these values appropriately. So this can be only possible by performing the pull-out load test, right? We have to perform pull-out load test at different elevation, maybe one near the top, just to represent this, because initially we may not have vertical cut there, right? So in the design phase, we may not be able to do that, but as this excavation progresses, we can do it. And also later on, if we found that this length are not adequate, we can install additional nails to overcome that. Now, whatever. So now my question is, can we trust this pull-out load test results? That is very important, right? We perform pull-out load test on field. So can you trust that? This is like, we have to be, especially when we are dealing with the lateritic soil or fine-grained soil. We have seen that like bond stress will be directly proportional to effective stress, right? We know that, right? As depth increases, confinement will increase, so bond strength will be higher. But in a partially saturated soil, not generally in sand, whereas in fine-grained soil and lateritic soil, residual soils, we can have this apparent quotient. See this equation, you see effective stress as two components. This is the net stress. We call effective stress minus air pressure. U is air pressure plus chi is actually a effective stress factor or effective stress coefficient into difference between air pressure and water pressure, because it's a partially saturated system, not a fully saturated system. So this difference we call S section or metric section. So we can say effective stress is equal to sigma plus chi S. See, this chi S is the additional effective stress due to apparent quotient. Okay. Now, if you are performing, so now if you write the shear strength equation, you know that shear strength is equal to under quotient plus effective quotient plus the sigma tan phi, right? This is what we have learned, right? But in case of a partially saturated soil, you're going to have one more component, that is because of the suction. So this equation is more simple. Last one, first two are for any, you will have it for dry soil and saturated soil, whereas third term will be there only for partially saturated soil. This is what we call apparent quotient. In partially saturated, this will be very high. Now, if you are doing this pull-out load test in partially saturated condition, the resistance you observe will be very high. Now, during rainfall infiltration, during rainy season, like monsoon, what is going to happen is as water infiltrates, this apparent quotient is lost. So you don't have the third term, right? So you don't have that, so you have to be very careful. Either you have to perform this testing in monsoon, pull-out load test in monsoon, or else we have to account for it. Okay, we have to somehow we have to calculate based on the soil water characteristics of soil, SWCC, we call SWCC curve. We can compute KES value, and based on the moisture content present at the time of pull-out load test, we can approximately calculate this apparent quotient and account for that. That is not typically done, especially in partially saturated soil. We have to be very careful. Now, in addition to this, so basically in rainy season, this is, we don't have apparent quotient. Okay, that is not there. Apart from that, this water is going to percolate, infiltrate. That is going to exert an additional pore water pressure on the phase C if we don't provide adequate drainage system. That also we don't generally account in the design, right? We assume that there is an adequate design drainage provisions and there is no excess pore water pressure. That is also not true. Similarly, sometimes if it's a sandy type soil and all, sometimes because of the seeping water, some soil sand get fluidized, and also this interface friction can further decrease. These all together can contribute to a decreased pull-out resistance in monsoon, and eventually cause the failure of the system. Okay, so we have to be very careful about the accommodating suction effect into account. Similarly, creep. You know that you have learned creep, all of you know what is creep, but this deformation under sustained loading, right? So in soil also, especially fine-grained soil, that function of fine content, what is going to happen is not only fine content, other aspects as well, this soil is going to deform. Okay, this deformation, when this soil is going to deform, what is going to happen is there will be if there is a strain softening behavior, pull-out resistance will decrease. Secondly, because of this creep deformation, there will be an additional pressure on the facing. A nail, which means nail force increase, right? More pressure on the facing means more load on the nail. Means we can expect about 15% increase. So we have, so we don't directly include that in the design, but what we can do is we can consider an appropriate reduction in bond strength value you consider in the design to account for this creep effect. Also, we can do creep test, just like that pull-out load test. We can perform, for a longer duration test. We keep one load and leave it for a longer duration. That way, we can perform creep load test as well, or creep pull-out load test as well in soil. And one of my students is doing research in that direction now, creep behavior of lateritic soil. His plan is to do some, he has already started doing some model studies. Then we are planning to model, if possible, some trial wall and monitor it. Hopefully we'll have some good results. Now, this part, detailed soil investigation, that is also very important. Like both Morth and FSW are highlighting this. We have to perform detailed soil investigation. Here you can see that this is the solid line is the alignment of the nail. See here, actually what FSW are recommending is to perform the boring along the alignment at every about 30 meter. This is 100 feet means 30 meter. Then one at back side, see this is a cross-sectional view, one at the back side and one at the front as well. So one front, if the height of the wall is h, one at the front you can have at a depth of 1h, and near the wall and at the back you can have 2h depth. But this is not done properly. We may have a single borehole data and we are performing the entire design for a long stretch based on a single borehole data. That is actually, as I told you, especially residual soils, soil is highly variable, and you performing design with a single borehole is, people want to save, as I mentioned in that that meeting, people want to save on the soil exploration. They think like it's a wastage of money, but that is not true, right? We have to, for proper design or adequate design, we have to perform adequate number of boring. So based on this, we have to come up with correct soil profile and soil properties for each layers. And you have to use that for the design of soil nail and global stability analysis, all the stability analysis. But that is not done regressively, maybe 1 or 2 borehole maximum, that's it. Even that both Morth and FSWA are insisting the same, but still we are not doing that. Similarly, we have to locate groundwater table, and that has to be considered appropriately in both in soil nail design and global stability analysis. That has a huge role, especially on global stability. This location of water table can significantly influence the factor safety. Because sometimes I have noticed if the factor safety required is 1.5, we'll have 1.49. According to the codal provision, it's safe, right? It's less than 1.5. But if we haven't considered any of these parameters, soil, if there are some mistakes in soil parameters or stratification or groundwater table, what is going to happen? This will exceed 1 point, it will be less than, sorry, the other way, if we have required is 1.5, and if the value is more than slightly more, like 1.5, 1.52, if these parameters are slightly off, it can come less than 1.5, right? Or sometimes it can come, even if it's 1.5, it's fine, it's safe. as long as it's more than 1, but sometimes it can be 0.99, something like that, and fail. Yeah, so because that's why factor safety we have to consider very carefully, because we are actually whatever uncertainties we are putting in this 1.5 margin or 0.3 margin, whatever. Okay, so we cannot assume and say that I have considered factor safety of 50% extra. That is like many things are. There are many uncertainties, right? Unlike other like a field like structural engineering, like concrete property or steel property, soil properties are significantly varying. That too we are not identifying properly. Okay, now drainage system. As I told you, this is one of the most important system. We have to provide a proper system, drainage system to control surface water and groundwater during and after construction. Not only during, but after construction as well. So there are different types of, you can see like in vertical strip drain, like some geocomposite we provide at the back side, just behind the facing. Strips. I'll show you some images in next slide. So these are vertical strips. Then we can put V-poles. You can see V-poles are like about 50 to 100 mm diameter, and length can vary from 30 centimeter to 60 centimeters. Sometimes it can be even more. And sometimes, like if you are expecting, this retention zone, if you are expecting some pore water pressure issue and all, we can put some longer pipes, okay, to ensure that this dissipate or they remove this pore water pressure by allowing seepage. And also at both the top and bottom, you should have interception ditches. Here you see concrete ditch. This has to collect surface water from the top. And in bottom also you see we have to either provide a toe drain or foot drain like this. Actually the water from this filter, strip drain is coming to this one through a V-pole, and then this is carried. And also as much as possible here at top, here we have to provide appropriate vegetative cover to prevent permeation of water into the retained field. So this is very important, because we have to use this. Generally we use thumb rule, like typically the spacing is we consider as a clause. We pole and all we consider spacing that is approximately equal to the spacing of the soil nail, or we put in between it. So we have to provide and we have to ensure that they are working properly. We have to cover it. Backside of this should be covered properly. Otherwise, water is going to, this fine is going to ingress through this one and eventually block this. So this image you can see strip drains provided for a soil nail. See, these are geocomposite drains. And this is actually you can see here the schematic diagram in square pattern. These are nails, and you have vertical drainage strips provided here. Then here some toe drain details you can see here. This is a simple toe drain with finished grade. This water get collected here and carried out. Then here actually instead of a toe drain you have a foot drain. Basically this is actually a sand filter. You can see sand drain, gravel drain, where you have a perforated pipe inside. Then it is wrapped by a filter fabric. So there are different approaches you can try, but ultimately we have to ensure that we have to have adequate drainage. So this is going to go, because as I mentioned, we don't consider pore water pressure into the design. Then now the question is, why don't we consider? The thing is, if we consider, it will be an over design. It will be very costly. So to minimize the cost, we are not considering, but we are assuming that there is no pore water pressure as we are providing adequate drainage provision. So this drainage in any structure, drainage is whether it is a reinforced retaining concrete wall or any geotechnical structure, drainage is very important. Now coming to my conclusion, I think 9:15, right? Yeah.
Yes.
So here you see the major points we can. I want to put forward from the ensure stability of the structure, soil nail wall, and avoid any potential failures. One is, we have to follow proper stage construction practice. That is very important. Then, we have to perform a detailed geotechnical investigation before design and execution. No compromise on that. We should not, for any, I'm just telling you, like not just for soil nailing, any structure, we should not compromise on geotechnical investigation, because after effect is like you may save maybe a few lakhs or even sometime less than that, but at the end, if a failure happen, how much we have to spend, that we have to always keep in mind. Then design should always comply with all the relevant standards and codal provisions. That is very important. Most sometimes we don't do that. That whatever dimensions are given, we should follow, because codal provisions and all, they have this is actually prepared by experts, right? The codes or standards, whatever. So they have actually proposed this based on something. So we should not overrule that. We have to follow that, right? Otherwise, we don't need to use this. What is the point of having Indian standard codes or IRC codes or both, whatever? There is no point in having such things, right? Then we have to check stability of the structure against all kinds of failure modes we discussed, which we don't do. We have to do that for all. Then we have to perform field pull-out test and verify the nail capacities. Initially, of course, we can use presumptive values, but we have to verify it. That is very important. Then, especially in fine-grained soil and residual soils, we have to consider the suction effect and long-term creep behavior. That has to be considered in your pull-out capacity as well, pull-out resistance obtained from the field load test. Then, as I mentioned in the previous slide, we have to provide adequate surface and subsurface drainage systems. And we have to provide both initial and final phasing, okay, as per design standards. Because sometimes we skip final phasing. Most of the time we try to skip final phasing, okay? People think like that is only for aesthetic purpose, the final phasing. That is not true. Otherwise, we have to ensure that the initial phasing has to be adequate, but that may not be. So we have to provide final phasing. Then if you are like especially tall soil nail and all, we have to perform continuous monitoring. Even though it's safe, for the time being, maybe because of suction effect and all, maybe during next rainfall, monsoon, it may fail. We don't know. If it's vulnerable to any, or you are expecting potential, we have to monitor it. We can monitor whether there is any deformation. If the deformation is exceeding the limit, then we have to send to the accordingly they managed to divert the flow of seeds. It has withstand this critical seasonal changes. PhD scholars who have already worked on, have already completed on this and are currently working. So actually my 5 students were working on soil nailing area and 2 have already graduated and 3 are working on this, but they are actually focusing mainly on pull-out resistance, but we're trying to come up with some different grouting system and all, and also how infiltration affects, how creep affect, like that. So I didn't.
Sir, you got muted. Sudheesh, sir.
Okay. Yeah. So I think, I would like to thank my research scholars who have worked in this direction. And so we are working in this, mainly focusing on soil pull-out resistance and overall behavior, especially upon rainfall infiltration. So I haven't actually included that in this lecture. I thought I would like to I would focus on more on the how this soil nail works and what can cause potential failure. Okay, so I think I have probably taken, I think 10 minutes extra, right? I think.
No problem. Yes, sir. So,
because it started at 8:05 and then we have in between 2-3 minutes. So I think.
Yes, sir. Yes, of course, I can
understand.
understand.
Thank you. Now I can take questions.
Yes, participants, dear participant, please unmute yourself and come forward with your questions and queries. Sami Abbas, sir, hope your question has been addressed in between this.
Yeah, my question was addressed, but now I have a different question. Based on the failure plane, can we decrease the length of the uh, reinforcement bar at the bottom because the failure plane is, or we are using commonly
Yeah, actually, typically we use the same length for all the nails because for convenience. But generally we need longer nails at top, typically, because as I told you, because that we are considering the pull-out resistance only from the the zone, the non-yielding zone. But some special circumstances and all, you may need to consider longer nails at the bottom as well. That also depending on the soil condition you have there. Okay, maybe soil stratification is going to vary from top to bottom, right? But one thing we have to be careful is this, when we perform the analysis, like when you use any software package, what may happen is if you are using the same length, okay, for the design, it may underpredict the pull-out load on the topper nails, especially the nails in the top first half, h by 2 height. So what is recommended is from probably for the top bottom portion, for the analysis purpose, we consider a shorter, like a decreasing length from the middle to the bottom. We consider decreasing length. That way, we are fooling the system, fooling the software. Okay, so the program will calculate higher pull-out load on the topper, and we'll design for that. We'll consider that. That is just for fooling. FSW is also recommending the same thing to do that. So, but we can, like, especially considering the global, if you think like global failure surface you want to change, in such cases you can consider, you can consider different nail length. But for convenience of the contractors, we generally go with because otherwise they have to always check the drawings and do it one by one. Instead, generally they go with the same length. I hope I answered your question, or if you have any connected question, yeah, please.
I earlier asked about this degree.
Yeah.
I think one slide has been shown about this. We can vary up to 25 degree and
Yeah.
about 10 to 50, 25 degrees. I
Yeah.
hope it
Yeah.
is right.
Yeah.
What is the calculation? It is based on the software calculation, or it is
Yeah, actually, you mean like a 10 to 25 degree, right? That is actually, that is, hello, am I audible?
Yes, sir,
yeah.
you're now audible, but it is just the
Hello?
acknowledgement slide is
Yeah.
being seen.
So, yeah, that is not based on this software analysis, but as I told you, we need can keep it horizontal, but the installation difficulty is there. Okay, but but at the same time, if you put like very large value like 30 degree, like 45 degree, then it's the its contribution will be less, right? Because we have this wall vertically or nearly vertical. So you need, if you put like this vertical, like this inclined, this contribution will be less, right? So that's why we, as much as possible, we try to keep it horizontal. But some studies, recent studies have shown that when you have some it's increasing with increasing the inclination, it's like pull-out resistance slightly increases, then go in the opposite direction. So studies are going on, but this is basically, my understanding is a thumb rule, not based on numerical modeling. Like we consider 10 to 25, but typically we limit to 15 degree. Typically, industry practice and all, we generally consider 15 degree.
Sir, you said about initial phasing and secondary phasing. So, what is the initial phasing? That when we are excavating, we will be providing one phasing, soil
Yeah,
nailing, and providing first nailing, first
yeah,
phasing, and
yeah,
second.
correct. Yeah. That is initial phasing. I'll take that slide. Uh,
One more question is that if what is the thickness of this shotcrete we are preferring for this?
yeah, shortcrete actually, yeah, we have to consider, we have to design it. Okay. But typically, what is recommended is about 75 to 200 mm for initial phasing and final phasing of 200 mm. But we can we have to perform structural design for it, like based on the loading on this one. That is what that for last 4 modes of failure are considering the structural failure of the facings mainly, right? One is structural failure of nail, and the other 3 are structural failure at the facing. So we have to perform proper design for that. Otherwise, yeah, we have to at least consider this whatever is recommended in the standards, because that. So here shortly, yeah, initial question, first question. Initial voice spacing is done during the excavation. Like, for first, you can see first lift excavation is done, then we are installing the nail, then construct the initial phase. Then only we go to the second lift. Okay, then we perform. So by the time we complete place, then final facing is done later. Okay. Is that clear?
It is
Clear,
almost
sir?
clear, but I have another doubt regarding how we can provide this boring.
Yeah.
Is this machine itself required, or can we do at our sites also? Can we adopt this at our sites also?
No, I didn't understand the question. You're talking about this drilling or borehole, soil investigation?
Not a borehole. I was asking about this horizontal boring. We are using this
Yeah,
horizontal drilling. Can we
yeah,
adopt
yeah,
this
yeah.
at our sites also
Y-
without this machine?
No, are you asking for soil retaining,
Our side mean?
Sameeba, sir? For normal soil
No,
retaining, are
actually,
you
this is
asking
like
for?
here you can see.
No, we are actually using
No, actually, yeah,
top-down
yeah, you're talking about soil
procedure.
nailing, or when you say your site means it's soil nailing, or
No, I was asking about
yeah,
soil nailing itself. But what instrument we are using for this drilling purposes for this?
yeah, need to use the exact system. Ultimately, what we are doing is here you see like an excavator type thing, and that is holding this thing, right? Okay, this is not that difficult. We have a guide. This is actually guiding mechanism. Then we are actually using that drill. This is not a very complicated thing. I think this is like the if you have if you are asking me, like, if you can use it on your side, me definitely you can use it. It's actually a photograph from Kerala only, so yeah, it's readily available here. Yeah, any other question?
Yeah, next question.
Yeah, Sudheesh, how are you? Annapurni here. Am I audible?
Yes, Sudheesh, sir?
Sudheesh is there?
Yeah, 1 minute, ma'am. Some technical
Yeah.
issues.
Yeah, please.
Yeah, hi Sudheesh. So, see, I think
Hello. Yeah.
yes, nice presentation. I think one more important point that will guide the stability of the
Yeah,
slopes
thank
with
you.
soil healing, which we need to consider, is the base angle at which the slopes have been cut. Considering the soil parameters. Okay, considering lateritic soil, which has
Yeah,
either
definitely.
porous
Yeah.
silt content, and if we cut
Yes,
at 9,
yeah.
and then we expect that the soil nailing, after applying all the theories also that is mentioned in
Definitely.
NH, I don't think we'll
Yeah.
achieve any safety. I mean, this is how the factor of safety is. So that is another point which needs to be addressed based on the
Actually,
soil.
your voice is breaking. I don't know if it's for me. I think your
Sir,
voice is breaking, right? I don't know.
actually, there is
Or
some
if
problem with your network, sir. Your voice is getting
mine.
disconnected in between. Yeah.
Oh,
Annapurni
okay.
ma'am, can you come
So
again, ma'am?
if you don't
Yes, Divya.
mind, could you please, yeah, please, because
Yeah,
yeah,
Sudheesh, what I mentioned is with all the design guidelines and
yeah,
construction guidelines that
yeah,
mentioned, even if we follow the basic thing, of course, you will also agree that the cutting angle of the slope needs to be ensured based on the soil parameters. With the apparent cohesion, if we cut these slopes at 90 degrees and then
definitely, yeah.
we,
Actually, yeah. I didn't.
the whole,
Definitely. Yeah, we discussed that there also.
yeah,
Actually, here, even like, yeah, I was thinking to include that, bench nailing and all, but due to the time constraints, I skipped that part initially.
appreciate.
Like, yeah, actually, when most of the time, like, because we cannot put like 90-degree actually. That is
Correct,
another
correct,
issue.
correct.
Like, most of the time, like, yeah, even though we say vertical or nearly vertical, we have to, yeah, that is the importance of this soil investigation, a detailed soil investigation. Accordingly, only we can do that.
True,
Yeah,
true.
yeah. Thank you for pointing out that, Anapurni. Yeah,
Thanks, Sudhesh. Thank you. It was a
sure.
very
Yeah, hey,
nice
thank you. Yeah,
topic
I
and
didn't
much
know that.
needed.
Yeah, I didn't know that you are attending that. Yeah, actually, yeah, she's a very. Yeah, all of you know that, right? She's a very
Yeah, Annapurni
popular
ma'am.
designer. Yeah.
Yeah, we are really, really grateful for
Yeah,
having you with
thank
us
you for
today.
attending this. Yeah, thank you so
No,
much for
thank you.
attending
Thanks,
this. Yeah,
Divya.
Yeah,
Yes.
we will be
If
inviting you soon for yet another session like this soon.
yeah, yeah.
sure. I'll be
Then I should
happy.
have,
Uh,
I should have kept it open for her, right? Soil nailing.
no.
No, no.
It is
Yeah,
always good to hear and
We
learn,
will
yes,
be
I
Sudhesh.
was.
definitely, anyway,
Yeah,
we'll be reaching out to her because we were planning for a session even before during Curiad issue, and we announced
sure.
then itself like we will be having
Yeah,
it
right,
later. So,
yeah. Because they will have like more to tell based on their real world experience. Because we are actually
Yeah.
telling mostly on the academic perspective and research experience basis, but they will have more on their, you know, how they are actually practicing theory. That is more important, right? Yeah. Okay.
Yes, but listening to such sessions, enforces us again to, go back to theory and apply them as much as possible at the
Yeah.
site.
Right.
So it
Right.
becomes
That is.
a challenge. It's most of the times it's a challenge only. But still,
Right. Yeah. Especially, yeah. I think dealing with contractor is also a challenge, right? That is, yeah.
uh, only one
So,
point is, Sudhesh. See,
yeah.
when we are telling this geocomposite, to be
Mm,
put, though FHW is also telling that to be put on
mm,
as a drainage on the surface. Okay. So if you see the thickness of the drainage
mm,
composite is also, say, considerable. Okay, about 10 mm, 12 mm. It's a quite
mm, mm,
thick material,
mm.
or
Yeah.
even more than that also.
Yes.
And over that, when we
Yeah.
are, though we have this bearing plate and nails in place, when we are doing the short fitting,
Yeah,
there will
I
be,
totally
there
agree,
won't be,
especially in this type of soil, like, it's, yeah.
yes,
And
uh,
also when
uh,
we short treat, yeah, right.
e- e- even
Correct. So
without
when,
any drainage material, also the shotcrete wears off from the side. Of course, that is because of the 90-degree angle that we are doing. Okay, so of course, at slope, it may be advisable, say 60-degree or
and again,
70-degree or so.
yeah, again, my internet was connection was unstable, but yeah. But I think, yeah, actually, as you said, like, yeah, I think that is even FHW is also addressing that, like, when that,
Mm,
we have to ensure that how much area we are covering, because that's going to actually reduce the bonding between the, soil and the shotcrete,
correct,
especially in this
correct.
kind of, like, yeah, for soil with high content, yeah. We have is like uh, there is no connectivity between them. If some of them are not working properly, there may be some sort of you know localized pressure, and that can probably cause some some sort of localized deformation and all. But again, like if we have a like this two facing, then we don't need to much worry about that because this get distributed.
Mm. Right, that's it from my side, Sudheesh. Nice hearing you. It was good to again revise all the theories and enforce that, to follow it at site.
Thank you so much for
Yeah,
attending,
thank you.
ma'am. We
Yeah,
will be reaching
thank
out
you.
to
Thank
you
you.
soon.
Thank you.
No,
Thank
thank
you.
you for
Yeah.
taking this
Yeah.
topic
Yeah.
and bringing Sudheesh.
Oh,
Yeah.
thank you.
Thank you.
And any other questions, please? Any other questions? So if not, can I ask you a question, sir, Sudheesh, sir, if you don't mind? Yeah, we are running
Yeah,
short
sure,
of time. I know
sure,
that. One
sure.
more question.
Yeah,
Like
sure, please.
you were mentioning about
Yeah.
staging and the sequencing, right? 1, 2, 3, like that. Is there any particular time gap that has been calculated or to be considered before doing like one stage കഴിഞ്ഞ ഇത്ര കഴിഞ്ഞിട്ടാണ് second stage അങ്ങനെ ഉണ്ടോ?
Actually, again, somewhere in between, I lost the
Network.
connection.
Okay, fine.
Could you please repeat that question?
You were
Like I lost somewhere in between. Like again,
Okay.
connectivities. Yeah.
Is
Yeah.
an issue. So you were explaining about the stage of execution, right? 1, 2, 3, 4. Sequencing.
Again, I
Sequencing
don't
you
know.
were mentioning,
Yeah.
right, sir?
Yeah. Yes.
Yeah.
Yeah. Stage. Yes.
Yeah, sequencing. And in between this each and every sequence, because that was the main reason for failure that has been
No,
mentioned
sorry.
by more. Can you hear me, sir?
No,
No
basically,
problem.
yeah.
Yes. Come on, sir. Continue, sir.
Yeah. Yeah. Am I audible? I think.
Yeah.
Again, my internet is connection. Some reason I don't know why internet. Yeah. So this once let's say for the lift one, once the short treating is done, the facing construction is over, and once it is achieved, achieved adequate strength, we can proceed with the next one.
Is there any
We have to
particular
ensure
time
that
gap between that?
the short treat has achieved. Again, that depends on I cannot say how much time it is because probably the contractor may have more idea, but I feel once this has achieved adequate strength, whatever that short treat that facing strength is required as per the design, once that is achieved, we can proceed with the next one. So
Okay.
I think technically probably one week would be enough.
1 week.
After achieving this, we have to ensure that this is hydrated properly.
Okay.
Short treat.
Okay. It depends on the short
Otherwise,
treat
what is going to
strength,
happen?
right?
Yeah. Otherwise, when we perform the second lift, what is going to happen is there will be more deformation, right? So that deformation means there will be more loading on the shotcrete lining because that time, if the concrete hasn't achieved adequate strength, it may fail.
Okay.
I mean, shotcrete, not concrete, shotcrete.
Okay. Okay, so got it. So whatever in the picture you are showing us just the shotcrete, right? You have shown one more concrete finishing layer in one picture.
No, I didn't show any concrete, only shotcrete.
In addition to the shotcrete layer, one more layer, is there any additional concrete layer coming over it, sir?
Which one you're talking about?
Just after the meshing, this will be the final phase of it, right?
Yeah. That's it. Yeah, I haven't
Okay.
actually. Yeah, actually, I didn't show any final because sometimes what they do is we cannot differentiate. Once the construction is over, we may not be able to differentiate initial and final facing.
Okay.
Yeah, it will be if they are using again welded wire mesh and short treating for this final facing also, then we cannot differentiate. Yeah, but typically in here again I haven't seen that. I didn't pay much attention to that secondary facing here in India, but US and all, they are using concrete facing. Yeah, they have used concrete facing.
Yes. In one of your slides, I have seen that concrete facing. That's what on cross section.
Probably. Oh, really? I didn't. I don't know which one, but I don't have only shortcrete only. Probably
Okay. The initial slides, I think. Yeah.
Initial slide.
You
mean this one?
No, just after this, sir.
Not this one, right?
Next. I don't remember, somewhere I have. Yeah, just before this. The previous one, I think. That's slide number 13, I think. I think so. I've seen it somewhere in your slide itself. Yeah.
No.
It's okay, sir. No problem. So anyway, since we are
13.
coming to
Okay. Yeah.
yeah, no problem, sir. So is there any additional questions? Anyone
One
else?
quick question. Yeah, can I ask a quick question?
Yes. Yeah.
Yeah, so it's all about it's about the slope of the
Please.
fascia and the height of at what's the maximum height we can, or is there any height restriction for adopting the soil nail technique? Yeah, up to this much height we can adopt this much, and so is there any height restriction for that? And actually, from the previous slides, you have explained about the slope. It's almost vertical, or have I some slope? Is there any safer slope like 15 degrees or 20 degrees, like any thumb rule from previous experiences?
Actually, this height, again, it depends on the soil profile. Actually, like what type of soil it is, we can consider. If you have soil condition is not that favorable, we can consider like soil nailing. You'll have a horizontal platform. For that case, maybe you can consider 5 to 6, like maybe 5 to 7 meter height for each. One segment, then a horizontal bench, and then. But in one constraint there is you should have adequate right of way. That is a challenge what I think typically the designers face. They may not have adequate the right of way, especially this our we have a space constraints, right? Especially in Kerala context and all, we don't have much acquired land. That case we don't have, but to be on safer side, it's better to provide a bench and acquire more land and ensure adequate. And also, if you ask me, in such, for example, in lateritic soil and all, what slope angle, I would prefer maybe like a 70-degree or so instead of going with vertical. Yeah, we can, we have to. That is basically I'm just telling you based on the site visits and all. Yeah, we again like all this can depends on the soil condition. If you have a very good soil condition like hard laterite and all, you can go steeper. But otherwise, what will happen is this. Even though initially you are providing nearly vertical, it's going to eventually there will be deformation and sometimes it look like overhanging, but it is not. Initially they cut it vertically, but now it looks like overhanging. That is because of a deformation. So in this. Ideally, I would suggest maybe stepped nailing, so nail wall with benches of adequate width. That is going to significantly increase the factor of safety, and also that will reduce the required nail length.
Okay, sir. Thank you.
Any additional questions? So if at all any questions are there, in addition to this, please do connect with us so that we will get in touch with Sudheesh sir and we'll get it addressed.
Please, if you have any additional question, please share with me. If I know, I will share, and I will also do. If I don't know, I'll try to find it out. Then let you know.
Definitely,
Yeah.
sir. And with this, since the time is becoming like 9:45, I would like to conclude it at this point. I'm inviting our respectful engineer Ashik sir for giving a vote of thanks.
Good evening all. ഇന്ന് നമ്മുടെ സുധീഷ് സാറിന്റെ ഒരു സെഷൻ അത് ഫസ്റ്റ് ഓഫ് ഓൾ എനിക്ക് തോന്നുന്നു എല്ലാവർക്കും ഇങ്ങനെ ഞാൻ ഈ പറയുന്ന ഒരു അഭിപ്രായം ഉണ്ടാകും തോന്നുന്നു. ഒരു ക്ലാസ്സിൽ ഇരിക്കുന്ന ഫീല് സെയിം ടൈം നമ്മൾ ഒരു സൈറ്റിൽ ചെന്ന് ഒരു നറേഷൻ, ഒരു സൈറ്റിൽ നിൽക്കുന്ന ഒരു ക്വാളിഫൈഡ് എഞ്ചിനീയർ ഒരു നറേഷൻ കേൾക്കുന്ന രണ്ടും കൂടി സിങ്ക് ചെയ്തിട്ടുള്ള ഒരു വളരെ മികച്ചൊരു പ്രസന്റേഷൻ ആയിരുന്നു. ഈ മുന്നേ ഉള്ള സെഷനേക്കാളൊക്കെ കുറെ അധികം ക്വസ്റ്റ്യൻസും കുറെ ക്വസ്റ്റ്യൻസ് ഇനിയും ചോദിക്കാനും ഉണ്ട്. എനിവേ, താങ്ക് യു സുധീഷ് സാർ. താങ്ക് യു സോ മച്ച് ഫ്രം ICC for this wonderful session.
Thank you.
And all the participants, especially the office bearers, and for all the participants, thank you so much for participating. Thank you. Good night.
Thank you.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, Annapurni ma'am, too. Thanks to all ICC members. Yeah. We'll see again with the next webinar session soon. Thank you.
Yeah. Thank you. Thank you
So
all.
Saturday
Good
night,
night.
9:45,
Yes,
and you have
yes,
40 people.
Thank you.
yes, sir. Yes, sir.
Commendable.
Thank you, ma'am. Thank you so much, sir, for your time.
Okay.
Thank
All
you.
right.
Yes, sir.
Great weekend. Bye-bye.
Yeah.
Yeah.
Thank you.
Bye.
Thank you. All right. Yeah. Bye. Yeah. Good night.